Hello and welcome back to the seventh lecture of the Python tutorial series. Till now in the last lecture we saw how to use mathematical operators and how mathematical operators, especially plus sign and asterisk, that is multiplication, works in case of strings, which are known as the operations are known as concatenation, that is with plus, merging, and then repetition or replication with the multiplication sign. Okay, so before we move forward to the concept of containers, let us briefly discuss a bit more about uh, concatenation of strings. So as we saw that there is a restriction that in concatenation strings can't be concatenated with a numeric type. However, if at all you wish, there is a requirement and you need to concatenate a string with one numeric type, then there is a way out. So what we can do is, let's say we have to merge high with 4. So high is a number, is a string, and then let's say 4 is a number, or let's say 41 is a number. Now if we try to execute this, we'll see that this line will give us one error because we are trying to concatenate one string type with one numeric type. Okay, let us see. So can only concatenate str to str, that is string to string and not int. Okay, so but however, if you have to, if at all you have to, there is a necessity that you have to concatenate, then there is a way out. In that case, you can convert the numeric type first to string and then concatenate. In order to convert a numeric type to string, what we use is known as str function, str, and within the this parenthesis of str, okay, within the after str, open simple brackets which are known as parentheses, and inside it put the number that you want to convert to string. Okay, so if I see the result, you can see it got converted. However, this high 41 is now one single string. So it's normally it's not possible to extract this 41 normally from this as a numeric type. Okay, though there are ways and means, but this 41 is a part of this string high 41. Okay, so there is a way out. Although similarly, you can just make it anything like, let's say, 99. Okay, then you can see it still works. So any numeric type, if you want to convert it into string, enclose it within str followed by simple brackets which are known as parentheses. Okay, in other words, str function. See, before we start discussion with start discussing this one containers, we'll just like to point out that wherever in Python we come across a word followed by simple brackets, the such words are known as functions. For example, print is a function because immediately after print you will see a bracket starts, which is known as parenthesis. Similarly, in case of str also, you can see immediately after the word str, a bracket start inside which we are putting some values. So any such word in Python which is immediately followed by parenthesis, now it doesn't matter within the parenthesis if you are having some values or not. Okay, so in that case also, you will say that the number, the words follow immediately followed by the parenthesis. It doesn't matter whether inside the parenthesis there is some value or some variables or some set of values separated by comma. Irrespective of that, that thing will be called as a function. So here print is a function, str is a function. Inside print function, we are also using str function. Okay, so this is the case. Okay, so now moving forward, just to mention here one more thing. So you can use print without any value inside. So that will result in one blank line. Result is blank line. Okay, let us see. We can see after 7, one blank line has been printed. Okay. Now moving forward to the discussion of containers. Now, why are containers used? As the name suggests, containers are the holders of the values, certain values. But why do we need them? Let us say the objective of our program. Let me first save the file as, let's say, fifth.py. Okay. To objective of the program, and as we discussed in the last lecture, to specify the objective as a comment at the very first line. So we'll say the objective of the program is to sum of two numbers. Okay. So there is a way. Let's say you want to print the sum of two numbers 10 and 5. So you can simply write print 10 and 5. Okay. Now this will display the, sorry, I executed the earlier program again. So it will display the result 15. Okay. Now, but there's a problem with this approach. The problem is that if we want to use the result 15 again, we cannot get it because you have displayed it and you have not saved it anywhere. So we generally, whenever we are performing computations, the result, we generally store it in some containers. Okay. So that will be useful in the sense that later on in some part of the program, if you again need to reuse the result which you obtained after performing some mathematical operations, you can use the containers and fetch the values from inside the containers. So what are containers? So containers are denoted by mathematical, arithmetic, this alphabetical symbols like A. You can write A is equals to 10, and then you can write B is equals to 15, and then you can use C will contain the sum of the contents of container A and container B, and then we will display the result of the container C. Now here one thing to note is, though it may appear that we are trying to display, we are trying to print C, but this is not string because strings are enclosed within quotes. So if we do not enclose any character or any sequence of characters of English language within quotes, then the Python accepts is, or Python thinks of it as a container and will try to fetch the contents of this container, okay, symbolized by this character. Okay, so now let us see how it works. So we can see that A and B have been added. The contents of A and B have been added, and the result has been stored in C. Now we can, with this approach, what is the benefit? That the result of C has not been lost. Okay, because the result of the sum addition of the two numbers 10 and 15 have not been lost, and they can be used later on by simply mentioning C. Okay, so this is one of the benefits. Okay, so now let us have some in-depth view of what happens exactly when you assign some value inside a container. Okay. So let us clear the canvas and fine. So containers. So what happens is, when you write A is equals to 10 or any value for that matter, what will happen is inside the computer's memory. So now when we talk of computer's memory, we only mean the primary memory of the computer, and the primary memory is what we say there of two types, though we will be this is the part of the second unit of the CBSE syllabus, but we are discussing it briefly here because it is imperative to understand the concept of memory in order to understand the concept of containers. Okay, so primary memory is there are two primary memories inside the computer. One is, we must be, most of us must be familiar with this, RAM and ROM. RAM is random access memory and ROM is read-only memory. So we must have heard 8 GB RAM or 4 GB RAM in our computers. So when we are saying the memory of the computer for program execution, hard disk memory is not used, because we must be knowing that memories are of two types in the computer. One is primary memory and the other is secondary memory. Okay, those computer directly uses only the primary memory. This is the only memory that is visible to the computer or the CPU directly. This secondary memory is not visible to the or accessible to the computer directly. And here we have hard drives, hard disks, and pen drives, flash drives, or SD card, whatever we insert. So this comes under secondary memory. So all the program execution takes place in the RAM of the computer. So now we must have heard that we have 4 GB RAM and 5 GB RAM, 10 GB RAM. So what do we mean by that? GB stands for gigabytes. Okay, but what is it? Now we must have seen in our course of studies that there is, in order to specify the magnitude of any physical quantity, we generally use some set of prefixes like deca, hecto, kilo, mega, giga, tera, peta, and we also have something exa. Then I think there is one zeta. So what is the meaning of it? So when deca, and just to point out, the basic unit of a computer's memory is bytes. Okay, so you can think of 1 byte as one store cell where you can store any value or the content inside. Okay, so basic unit is byte. So when and the magnitude varies, like 10 to the power 1, 10 to the power 2, then 10 to the power 3, and then here on we'll add 3 to the powers, 10 to the power 6, 10 to the power 9, and 10 to the power 12, then 15. Okay, and you will have 18, and finally if I'm not wrong, this will be 10 to the power 21. Okay, so this is the hierarchy. So when we say our computer has let's say 4 GB memory, what we mean is 4 GB, that means gigabytes, that is 1 gigabyte is 4 into, we can see giga is 10 to the power 9, that is 10 to the power 9 bytes. Okay, so what happens exactly is, in the computer, the RAMs, there are, that means this many blocks, memory blocks are there in the computer. One, you can have another, 2, 3. So it starts with, let's say your numbering starts with 0, not 0, and we'll say block number 1, 2, 3, 4. It will go on till 10 to the power 4 into 10 to the power 9, whatever this number is. So it will go to that value. So these many the single byte blocks are available inside the computer. In case of 4 GB RAM, if it is 8 GB, then 8 into 10 to the power 9 bytes or the blocks will be available, and each of the block is capable of storing certain values. Okay, so when we are specifying containers, okay, let us move down a bit. Okay, so now coming back to our discussion. So when we say A is equals to 10, what happens exactly is, computer in the RAM, that is RAM which may be 4 GB, 8 GB, and which is having, let's say, around a large number of blocks starting from 1 to uh, 10 to the power 4 into 10 to the power 9 block number. Okay, so that many blocks are available inside the computer. So let's say computer, what it will do is it will randomly select any one of the available blocks inside the computer, and inside it will put the value that you have specified here, 10. Okay, so the value that we are specifying goes into one of the free bytes available within the computer system. Okay, it may be having numerous, and not all must be may be free, because some of the byte spaces are used by operating system, other running programs. Let's say you have opened some song and browsers. So let's say any one of the, let's say four blocks are available, and it will randomly select. There is no sequencing. So it's just like whichever it sees first, it puts the value there. Okay, so randomly, let's say it put the value 10 in that block, and then in order to specify it later, remember that key in which of the blocks it has put the value, it will specify this tag to it or this label to it. So this memory location will now also be known as A, so that later on when you need to fetch value, you will simply say A, and computer will look inside its large pool of available bytes, which byte or the which memory location has been labeled as A, and from that memory location the value of that container will be fetched. Okay, so let's see what happens. So in this program we did A is equals to 10, and let's say B is equals to 5, and C is equals to A plus B, and then we did print C. So what exactly happened is, when we specify, and as we know that a program runs line by line, that is sequence by sequence, first this statement will be executed, in second this, third this, fourth this. Okay, so let's say when executing this first statement, this one, A is equals to 10, like we saw above, randomly one of the free available byte spaces in the RAM will be selected. Inside it, a value 10 will be specified, and then this will be labeled as A. Similarly, in the next, randomly one of the available spaces will be selected in the from the free pool of RAM. One of the available bytes will be selected. Inside it, 5 will be put, and this will be labeled as B. Now, and then in the third line, contents of A. When we say A plus B, first of all, because it is not enclosed within quotes, this A and this B, computer will try to will treat it as a container and will try to fetch the value from it. So it will look into, whenever it comes across A, it will look inside its memory bytes which have been occupied, and will try to look for one of the memory bytes which has been or the memory locations which has been labeled as A in the RAM. So from there it will put bring the value and replace it here, 10. And then similarly from the B memory location labeled as B, or the RAM location or the byte location labeled as B, it will fetch the value and will replace. So it will be something like internally, first of all, this will be replaced as 10 plus 5. Then result of this will be calculated, and then this result is put inside C. So first of all, just a minute. So the result of this is put inside a new label. So first of all, 10 plus 5, 15 is created, and this 15 will again be saved inside one of the available spaces, and this spaces available bytes of the RAM, and this will be then labeled as C. Okay, and then finally in the print statement, when you write C and without quotes, so it will be taken as a container symbol, and then it will look inside the memory its RAM, and will fetch 15 from there, and then will displace it. Okay, so one thing to note here is, okay, first of all, whenever any equation any statement is followed separated by equal to sign, equal to is also known as assignment operators. Okay, so first of all, right side RHS, this is also known as R value. So in case of, whenever you write anything, let's say we write x is equals to 20. First of all, right side is evaluated, and if it is a single value, a memory location is reserved for it. that value is put inside that container memory location, and then left side value, okay, that is known as, also known as L value, is put associated, or that label is put on it. Okay, so similarly, however, if let's say y is equals to 20 plus 30, this line computer comes across. So always R value, or the right side of the assignment operator, is evaluated first, always. So R value will be evaluated. Remember, whenever you this R value is encountered, if there is an expression, this will be simplified to a simple single value, single result. That is, first it will be converted to 50, then this 50 will go inside what is known as a reserved memory location. Memory location will be reserved and will be associated with, after one final value is arrived, then L values label will be put on, that is before the equal to sign, whatever symbol you have used will be put with that memory location. Okay, so this is how our program works. Okay, so in the next lecture we'll further explore how to write a basic and simple programs. So for now we have only seen addition of two numbers, two fixed numbers, using first of all storing them in containers labeled by, specified by A, B and C, and the result is stored in C. We also saw that R value is first, that is after the assignment operator or the equal to sign, first, that is put in the container. If it is an expression, that is evaluated to a single value, and then it is put inside a container, and then L values label is put on that. Okay, so we'll continue with the discussion on the containers in the further lectures. Thank you for now.